Child with Hide Science. Just want to go over a little bit about nuclear decay, radioactivity, such as that. Get started on that. So I want to talk about the radioactive nucleus. So a radioactive nucleus will emit radiation. Those words are very similar. People get them confused, but we're going to try to iron that out right now. So right here we have a nucleus. The larger nuclei tend to be more unstable because all these protons, and as we know, the more positive charges we get in an area, the harder it is to hold them together because they repel. Like charges repel, opposite charges attract. These are electrostatic forces you should be aware of by now. The force of the nucleus is very strong, stronger than the force of gravity, but it only extends out so far. So we're holding the protons in. It's already tough to hold these protons in, but then as they take up more space and you get more in them, now we start to exceed the range of the nuclear force because it doesn't extend very long, and it just gets really tough to hold all these together because they're pushing apart on each other. So in an attempt to become more stable, all right, it will become radioactive. It'll rearrange itself. It'll try to do something to make itself be more orderly or exist at a calmer state, if you will, right? And nature don't want to be stressed out. They're going to do something to make itself less stressed, right? So there's three ways we'll talk about how it can emit this. And once this radioactive nuclei emits the particles, the emission of these is called radiation. So the radioactive nucleus will emit out the radiation. I'm going to put on marker. Here it is. All right. So the first type we got is going to be alpha. What's going to happen is a little chunk of this nucleus is going to get shot out. So right here, all right, this is 2 protons and 2 neutrons. All right, this is going to get shot out, right? Emitted out. All right, so we got 2 neutrons, 2 protons. All right, this in itself is basically a little nucleus. It's like a little helium nuclei. We got 2 protons, which we can use to identify as helium. So an alpha particle is simply just a helium nuclei. I don't have any electrons, but everything else is there. So this is our alpha. That's our alpha particle. The next particle, a little bit weird. All right, so on you, and you know that electrons, right? Electrons exist outside the nucleus in the electron cloud. Well, here's where it gets weird. One of these protons or one of these neutrons in here break down, and it splits. And you'll either create a proton or a neutron, and in the process of that, it will emit out an electron. There are no electrons in the nucleus, but beta decay will shoot a electron out of the nucleus. I know it's weird. All right, but that's just what happens. You get the breakdown of the proton or the neutron. In our case, usually we'll talk about the neutron breaking down, creating a proton and an electron as well. Again, this is called beta decay. And once it's shot out, it's just a normal electron. So now we got this radiation in the form of electron. All the properties of electrons are true for this beta as well. It's not a unique special case electron. It came from a special place, but it's just an electron. Finally, the last one we'll talk about is the release of just straight energy. Right? And this will be in the form of, you should already be familiar with this, a gamma wave or a gamma ray. Right? This gamma ray, as you're aware, is the highest energy wave, it's the highest frequency wave, and it has the shortest wavelength. A lot of energy. This one is the most dangerous. The reason why it is the most dangerous, it is very small, right? It has no mass. No mass. It's just pure energy. And what's even more sketchy about it is it has no charge. So basically it's small enough to get through things, and it can even get through electrical and magnetic fields because it has no charge, So there's really nothing, it's kind of like the stealth bomber or something we're trying to create where we could just go straight through the enemy's defenses and not get detected. That's what gamma can do. Just go straight through any defenses, gets in there, ionizes your DNA, and you'll die before long. So you won't know you're dying until you start throwing up. But very dangerous, very high energy wave. The only thing that can really stop this is extremely dense particles, so some lead or very thick, about 2 feet thick of concrete. Beta's kind of in the middle, kind of like we associated liquids. It ain't really never the best or the worst of anything for the most part. It's just kind of stuck there in the middle. Alpha is the largest, has a mass of 4, right? Has the biggest charge. So because it has 2 protons and no electrons, there's no balance of charges. So it just simply has this charge of +2. So alpha is very easy to stop, right? It's big, right? It has a charge, the biggest charge of them. It's easier to catch big objects. If I throw you a giant pillow, you're gonna catch it fairly easy. If I throw a little ping pong ball at you really fast, it's gonna be a little bit more difficult to catch. And then the charge makes it even easier to do so. Alpha and beta will change the way this nucleus is. We call this transmutation. So what it's going to do is it's changing the number of protons. Beta tends to add 1, alpha tends to remove 2. Anytime you alter the number of protons, you're going to get a new element entirely. Transmutation. Yeah, that's pretty much it. That's a rundown of alpha, beta, and gamma decay from Hyde Science. See y'all later.